This is my pre-algebra course. Today we're going to learn one-step equations. If you haven't done the homework from the last class, do that homework completely and correctly before watching this video. Now in the last classes, we learned how to simplify expressions. But in this class, we're going to learn how to solve equations. So let's get started. We have x minus 5 equals 3. It's very important to understand what this equation is asking us to do. This equation is asking us to find x. It's asking us to actually find what x is. In the previous classes that we did in this course, we weren't trying to find x, we were just trying to simplify expressions with x. But here they want us to actually find what number x is, because we have this equation which gives us clues to find the unknown, the variable. X again is called an unknown or a variable. Now you can probably figure out what x is just by looking at this equation. It's not that difficult. What number minus 5 equals 3? Well, I'm not going to tell you the answer. You could probably figure it out on your own. Well, I guess I will tell you. It's 8. 8 minus 5 is 3. And so a lot of these problems that we're going to do today are fairly easy to do in your head, but you must understand that the primary purpose of the class today is to learn how to write the steps that you need to take to solve an algebraic equation. So even though we can do these problems in our head, we have to show the steps. And the reason is we're going to do problems that have 2 steps, 3 steps, 4 steps, 5 steps, and maybe even problems with 10 steps, depending on how far we get in this course. It just depends on what I designed for the curriculum. So because you're going to do problems with so many steps, you have to learn how to do the various steps. You have to learn how to show how to read, and you have to learn how to read and write each step. And so the difficult part of this is not figuring out the answers. The difficult part is just showing how to figuring out how to read and write the mathematics. Again, that's what this course is all about. Most of algebra is just learning how to read and write the mathematics. And when you get to the more difficult equations, obviously you're going to have to use algebra, because when you get to the more difficult equations, you're going to need to show the steps, because we're not going to be able to do those quite so simply in our heads. So let's start with number 1. The first thing that you're going to do is rewrite the equation exactly the way you see it above. And that's extremely important. That's the first step. That's the first step for every single one of these equations, is rewrite the equation. You must rewrite the equation. So then what we're going to do is we're going to do what's called isolating x. And what that means is we're going to get the x by itself. The x is not by itself because the 5 and the negative sign are next to it. So we're going to have to get rid of this negative 5. And we're subtracting. This expression is saying we're subtracting 5 from x. So in order to get rid of the 5, we have to do the opposite of subtraction, which is addition. So the reason that we rewrote the equation is because we're going to add 5 to both sides. Now if we add 5 to one side, we have to add it to the other side. That's why I added it on both sides. If we do something to one side of an equation, we have to do that exact same thing to the other side. And the reason we have to do it to both sides is because if we don't perform the operation on both sides of the equation, then this equal sign will not be true. For example, let's say you have 7 equals 7. If I add 2 on this side, but I don't add it on the other side, then I'll end up with 9 equals 7. Well, that's not true. But if I add 2 on both sides, I'll end up with 9 equals 9, so the equation is still true. Alright, so because I'm adding the 5, these 5s are then going to cancel out. So I'll just write, I'll just do a highlighter instead of crossing them out. Usually you can cross them out. So those go away and you're left with x equals, and then we just have to perform this operation. 3 plus 5 is 8, and therefore x equals 8. So there's a lot of things going on there. And again, I know that you're going to want to do this in your head, but do not do this equation in your head. You must not do that equation in your head. Because we need to, well, you can do the equation in your head, but you've got to show the work. You must show the work. That's the most important part of the class today. If you don't show your work, you might as well not be doing this stuff. So please, please do what I tell you to do. Show the work. That's the purpose of this class. All right, so again, a lot of stuff going on there. We rewrote the equation, and we performed an operation on both sides, and we got our final answer. Now, here's a big question. Why did we have to rewrite the equation? Well, I kind of touched on that. The reason we had to rewrite the equation is because we had to add 5 to both sides of the equation. But you're probably wondering, well, why couldn't we just add 5 to this equation? Well, there's a very important reason for that. If we added 5 to this equation and then got our answer, then you can see what happens is we messed up the original equation. I can't see what the original equation is anymore. So if you go back and try to study this, let's say that I add 5 to the original equation, and then you take a screenshot of these notes and you try to study these notes for the test or for your homework. Well, the problem is when you look on this problem, you can't see the original problem. So you can't really do the problem the way it was intended to be shown to you, because you can't see what the original problem was, and that's a big issue. So that's why we have to rewrite the equation. So I'm going to get rid of that so you can see what the original problem was. Now, a lot of people say that you can solve this problem, and let me move this over temporarily. A lot of people say that you can solve this problem by simply adding 5 below the equation, and a lot of teachers allow this. Then you just end up with your x equals 8, and you're done. And it's so much easier to do it that way. And that's why teachers allow it, because you don't have to rewrite the equation. The problem is, this is not proper math notation. This really doesn't mean anything in the math world. Okay, if you write a 3 and then you write a 5 down here with the plus sign there, that's not really the way we write the operation in algebra. It's easier to do it that way, but in the long term, it's going to hurt you, because you're not going to be able to learn how to write the numbers on the same line. I want you to know that I'm aware that there are other methods for doing this, and I don't want you to use those methods. I'm teaching you how to prepare for the sciences and the engineering fields, and for high school entrance exams and college entrance exams. I'm preparing you how to teach, or how to speak algebra and read and write algebra fluently. And if you use these tricks, they may work in the short term, but in the long term, you're not going to learn proper math notation. So I'm aware of that method, and I do not want you to use that method under any circumstances. So I'm sorry to lecture you there, but I just want to head that off, because some students will try to use that method. Do not use that method in my class. And some people will try to argue. They'll try to say, well, I think it's better to do that. Please do not do that. You need to learn the proper math notation. Now, there's something else that I really need to talk about before we go on to problem 2. We talked about how there's an easier method to write the addition below the line, and I talked about how I don't want you to do that. But there's another way that makes there's another method for writing the operation that makes this quite a bit easier, and that is when you rewrite the equation, instead of writing the x minus 5 here, what you can do is you can move it over to the left, and that gives you room to write the plus 5 here. So we're adding the 5 on the right side rather than on the left side. So the reason that this is easier is because it's just it's more comfortable for students to interpret the addition when you write the plus 5 on the right side. And so most textbooks actually do it this way. They take the x minus 5, and when they rewrite it, they move it to the left. Okay, I want you to be aware that even though that method, like the method we discussed before where we add the 5s below the line, is easier, I'm still not going to use that method. And there are reasons that I'm not going to use that method. A lot of parents and students and teachers will say, well, you know, you're not using the correct method because this method is easier when you add 5 on the right. You know, that's what the textbooks use. That's just a better way. Well, I'm aware of all those easier ways, and I'm not going to use those forms of notation. And let me tell you why. There's 2 reasons. Number 1, you need to get used to adding a number on the left side of a variable. So that's just something that you're going to need to do. So I'm in many classes I'm going to start off easy and then obviously get harder and harder with certain concepts and notations. But with this class, I'm going to just throw you into the deep end immediately, and I'm doing that on purpose because it's better for you to start learning this stuff now rather than to have to learn it the hard way on a test. So that's one reason that I'm going to add the 5 on the left rather than on the right side, as you see in most textbooks. Another reason that I'm going to write it on the left side is because it actually makes it easier to understand what's going on to a certain degree. It's extremely important to understand that in every one of these problems, when I rewrite this equation, I'm going to write it directly below. I'm going to try to line up those expressions, and that way there's not going to be any ambiguity about where the x is or where the 5 is. So this equation is this equation here, and of course I need to add the 5 there eventually, so that there's no confusion about which 5 is which. So is this 5? Is this 5 here, or is it here, or is it here? I don't want there to be any confusion about that. So I'm always going to bring it straight down. Now, if I move the x minus 5 over, then that pretty much violates that principle, and it makes it to where you start to get confused about which letter came from where, which number came from its position. So I just want you to be aware that I'm doing it this way on purpose. I'm not going to write plus 5 below because that violates the basic notation. I'm not going to move the x minus 5 over, even though that's not wrong. I'm not going to do it that way because then I'm going to move the numbers out of alignment, and I think it's in the long run it's going to be easier for you to understand if I keep the numbers lined up. So again, I just want you to be aware that I'm aware there are easier methods to show the operations, and I'm choosing not to use those methods because in the long run it's going to be better for you. So I'm sorry to lecture you about that again, but if anybody has any complaints about it, I just want you to know that this is what's best for you. People may disagree, but trust me, this is going to be better for you in the long run. So is it going to be difficult for you to learn notation where you're adding a number on the left side of the variable? Yes, there's going to be many different types of operations that are going to be somewhat difficult to conceptualize in this class, but that's why we're only doing one-step equations today. So it's not going to be easy to pick it up, but once you do pick it up, you're going to be a lot better prepared for the upcoming classes. And the last thing I'm going to say about that is when you rewrite these equations, I want you to do the same thing. I want you to bring that equal sign straight down. I want you to bring the other numbers and letters straight down. I want you to do it that way every time because it's going to be easier for you to understand what's going on in the long term. All right, so step number 1, we're going to rewrite the equation. Step 2, we need to isolate the y. The y is not isolated because the 4 and the plus sign are next to it. So we have to get rid of the plus 4. The opposite of adding 4 is subtracting 4, so we're going to subtract 4 from both sides. Now this is an important point. If this 6 were moved over, then we could just subtract the 4 on the right side, and that would be very easy. But the problem is the 6 is not moved over. It's right next to the equal sign. So what you have to do is you have to add a plus sign and then a negative 4 over here. Adding negative 4 is the same thing as subtracting 4. That makes many, many students angry hearing that because they don't understand why subtracting 4 is the same thing as adding negative 4. But trust me, it's just something that you need to get used to. But this is something that is a big source of confusion for students. Now again, if I use that short method, if I use that method where I just subtract 4 down here, it's so much easier to do it that way. But it's not proper. Don't do it that way because the purpose of this course is to learn fluency in algebra. You're not learning fluency if you're using improper language. All right? I'm not doing it this way to make life difficult for you. I'm doing it because this is what's best for you. All right? And again, many teachers may disagree with me, but that's because most of them are not engineers and scientists. All right, so we're subtracting 4 from this side and adding negative 4 to this side, which is really the same operation. And again, I know that this is difficult, but you're going to have to get used to it. So now these 4's cancel out, which is why we did that in the first place. And then these numbers, negative 4 plus 6, that would be 2. And so y equals 2. Now again, you could have figured that out really easy just by looking at the equation, but that's not the purpose of this class. The purpose of this class is to get you started with proper math notation. All right, number 3. Now it's important for us to, well, first of all, let's just rewrite the equation. That's step 1. And then step 2 is we have to isolate z. We have to get it by itself. Z is not by itself because the 2 is next to it. So we have to get rid of that 2. So we have to ask ourselves, what is 2 doing to z? Now we learned in the previous classes that if a number is next to a letter, that means that the number is multiplied into the letter. It's multiplied by the letter. So we have to do the opposite of multiplication to get rid of this 2. So we're going to do the opposite of multiplication, which is division, but you cannot use this sign. We don't use that sign in algebra. Well, you might see it in rare cases, but maybe 99% of the time we don't use this sign in algebra. So we're not going to use that sign anymore. We talked about this in the previous class. We're going to use a fraction symbol for division. So what we're going to do, and this is going to seem very weird, this is all new stuff to you, but you're going to have to learn this. This is the language of math. You can't get around it. This is what you're going to do in high school and college and engineering and science. You have to learn this language. Okay, I didn't make this stuff up. This is just what you have to learn in order to go into upper math courses. And anybody that tells you otherwise is not qualified to say so. Trust me on this. If you read math textbooks, this is the notation that you're going to see. This is going to seem strange, but we're going to use a fraction sign for division. So that's dividing both sides by 2. The division sign is, let me get a thinner highlighter. This is the division, and this number is what we're dividing by, the 2. So we're dividing both sides by 2. Now what that does is it gets rid of the 2. The 2's cancel out. So we're left with z, which is what we want. We want to isolate it. And then over here we do 8 divided by 2. 8 divided by 2. So that would be negative 4. We learned that in the previous class. A negative divided by a positive is a negative. So I know that stuff is very, very strange, And I should get rid of these highlighters. I know it's very strange, but this is just the notation that you need to learn. Let's go to number 4. All right, so first step, we're going to rewrite the equation. And the second step is we're going to get x by itself. It's not by itself because the 3 is next to it. So we have to get rid of that 3. But we have to ask ourselves, what is the 3 doing to the x? Well, we just went over the idea that the fraction sign means division. So this is x divided by 3. So what is the opposite of division? The opposite of division is multiplication. So we have to multiply both sides by 3. But here's the problem. If we use an x, do you see the problem over here? That's very weird. That's going to confuse us because we have two x's. One x represents a number we don't know, and another x represents an operation. We can't do that. That's not allowed. So another thing that we could do is we could use a dot. That's actually okay. You can use a dot. But the problem with dots is if you have decimals like 5.1 or 3.7, then things start to get really confusing. You see all these dots all around here? So dots are not typically used. Sometimes they are, but 95% of the time dots are not used. So we're not going to use a dot. The most common notation that you're going to use in algebra for multiplication, and we went over this in the previous couple classes, is parentheses. That means multiplication. And I can put the 3 on either side. I can put the 3 on this side of the 5, but obviously I can't fit it there because the equal sign is there. And I can put the 3 over here, but again, I would bash up against the equal sign. You can put it on either side because of the commutative rule of multiplication. But that's not important at this point. So now these 3's cancel out, and that's why we did that in the first place. So we get x, and then we just have to multiply 3 and 5 to get 15. So the answer is 15. The unknown, x, the variable, is 15. All right. So we're going to try quite a few of these together before you try one on your own. Step number 1. What is step number 1? You tell me. We're going to rewrite the equation. That's correct. Now you tell me, what is step number 2? Step number 2 is isolate the variable. Isolate y. Y is not isolated. It's not by itself because the negative 2 is next to it. So what do? We do the opposite of subtracting 2 to get rid of that 2. So we're going to add 2 to both sides. So these 2's cancel out. And you just end up with y. Y is by itself now. And we just perform the basic operation over here. Negative 7 plus 2 is negative 5. If you said negative 5, you're correct. All right, on to number 6. What is the first step? You tell me. If you said rewrite the equation, you were correct. What is the second step? If you said isolate the letter, the variable, you were correct. So we have to do the opposite of adding 11. We have to subtract 11, and we don't have enough room over here. If the 8 were over here, then we could just subtract 11 like that. That would be easy. But 8 is not over there, so we have to do something very strange. This is what makes students very angry in this course. We have to subtract 11 by actually adding negative 11. So these cancel out, and you get z, and then negative 11 plus 8 would be, what do you think that would be? If you said negative 3, you were correct. So again, we're doing the same steps in each one of these problems. All right, now here's an example of a problem where it might not be so easy to do this one in your head. So we definitely need to use the algebra. This is one case where the algebra comes in handy because our answer is actually going to be a fraction. This is where we see the power of algebra. So what is the first step? You tell me. If you said rewrite the equation, you were correct. Now what is the second step? You tell me. If you said isolate the variable, you're correct. We have to get x by itself, but x is not by itself because there's a negative 7 there. So we have to do whatever negative 7 is doing to x, we have to do the opposite. So remember, when a number is next to a letter, that means multiplication. So we have to do the opposite of multiplication, which is division. To get rid of that negative 7, we have to divide by negative 7. And we have to divide both sides by negative 7. We can't just divide one side. I didn't mention that enough in the last 3 or 4 problems. Whatever you do to one side of the equation, you must do to the other side, or else the equal sign is not going to remain true, or to stay true. So now those 7s cancel out, and that's why we did that. And we get 8 over 7, and you can put the negative here, or you can put it here, which is probably the best place, or you can put it here, but typically you'll only see it in the numerator or in front of the fraction. So that's why it was not quite easy to figure out what x was in this problem, because x actually turned out to be a fraction. All right, so what is the first step? You tell me. If you said rewrite the equation, you're correct. And what is the second step? If you said isolate the variable, get y by itself, you're correct. So this is y divided by negative 2. Remember, a fraction means division. So y divided by negative 2. So we have to do the opposite of dividing. What is the opposite of dividing? The opposite of dividing is multiplying. And how do we show multiplication in algebra? 95% of the time, we show it with parentheses. So we're going to put parentheses. Whoops. I made a big mistake there. I have to multiply by negative 2, because I have to get rid of not just the 2, but the negative also. So I'm multiplying by negative 2. And the negative 2's cancel out on the left side of the equation, so I'm left with y. And then 6 times negative 2 is negative 12. All right. So let's see here. We're getting close to the point where you want to try some on your own. Let's do a couple more together, though. I want to make sure that you got this, because this can be kind of intimidating for students to do all this. So what is the first step? The first step is rewrite the equation. What is the second step? Get the variable by itself. So we have to do the opposite. We have to get rid of this negative 8, so we have to do the opposite of subtracting 8. The opposite of subtracting 8 is adding 8. If you said adding 8, good job. So now these 8's cancel out, which is why we did that in the first place. And remember, if you add 8 to one side of the equation, you've got to add it to the other side of the equation too, or else the equation doesn't remain true. So those 8's cancel out, you're left with z, and then on the other side you have negative 6 plus 8 is 2. So if you said 2, good job. All right, number 10. What is the first step? If you said rewrite the equation, you're correct. What is the second step? If you said get the variable by itself, you're correct. The opposite of adding 3 is subtracting 3. And this is where we get into an even more difficult type of notation. Now, if I move this negative 4 over here, then subtracting 3 is pretty straightforward. And we know how to deal with this expression. It's not an easy expression to deal with, to work with, because it's in a condensed form of algebra. It actually means negative 4 plus negative 3. But we can deal with that. But what if we have to put it on the other side? Because the 4 is over here, which means we cannot fit, if we're going to subtract 3, we can't fit it over here. We can, but it would be too messy. So what you can do is you can just write it right in front. Now I know that that seems really weird. And you're going to say, I would much rather just write the negative 3 down here. So I don't have to put it on the same line, but that you don't have that option. If you want to learn the language of mathematics, the language of algebra, you've got to put everything on the same line. That's proper math notation. So we had to put it right in the front here. So that looks very, very weird, but you're just going to have to get used to that. So now we have negative 3 minus 4. Well, first of all, we can cancel out these 3's, so we have x. And then we can go ahead and subtract or add these together, and we get negative, what do you think that would be? Would that be positive 1, negative 1, positive 7, or negative 7? Most students will choose at least one of those answers. If you said negative 7, you were correct. Again, I know that's weird notation, but you've got to get used to it now. All right. Let's see here. All right, number 11. So what is the first step? If you said rewrite the equation, you're correct. And what is the second step? If you said get the variable by itself, you were correct. So when a number is next to a letter, that means multiplication. The negative 9 is right next to a letter, so it's multiplication. We have to do the opposite of multiplication. So how do we, our opposite of multiplication is division. So how do we show division in algebra? If you said with the fraction sign, you were correct. So we divide, and these negative 9's cancel out, and you're left with y. And then negative 18 divided by negative 9 is 2. Remember, a negative divided by a negative is a positive. They're like signs, they like each other, so it's a positive situation. And whatever you do to one side of the equation, you have to do to the other side of the equation. All right. I'm sorry to repeat myself so many times, but it's extremely important that you understand this. Or else when you go to the homework, it's going to be very difficult. All right, so what is the first step? The first step is to rewrite the equation. So if you said rewrite the equation, good job. What is the second step? The second step is to get z by itself, the variable by itself. So if you said that, good job. So z is divided by negative 4. It's z divided by negative 4. So in order to get rid of the negative 4, we have to do the opposite of dividing, the opposite of division. So the opposite of division is what? If you said the opposite of division is multiplication, you were correct. So how do we show multiplication in algebra? Do you remember how we show multiplication in algebra? We show multiplication with parentheses. So we have to multiply both sides by negative 4. So now those negative 4's on the left side of the equation cancel out. You're left with z, and negative 4 times negative 9, what do you think that would be? If you said 36, good job. All right, so if you're having problems with this, that's okay. That's the purpose of this class, is to take care of the minor problems you're going to have, so you can do the homework without a lot of problems. Okay, number 13. What is the first step? You tell me. If you said rewrite the problem, good job. Again, I don't mean to repeat myself asking you these questions, but it's extremely important that you know how to do this for the homework and for the future. So now, what is the second step? If you said get x by itself, you're correct. So we have to do the opposite of addition. The opposite is subtracting 1. So if you subtract 1 from one side of the equation, you have to subtract it from the other side of the equation. But we can't write minus 1 over here because there's not enough room, so we have to write it over here, and it's very strange to do that, but you have to get used to it. So you end up with x on this side of the equation. These 1's cancel out. And we have something else that's happening that's very weird. We have negative 9 minus 1. That's the condensed form of the equation. That means negative 9 plus negative 1, so that would be negative 10. A lot of stuff going on here to show how to do the steps, to show how to write the steps in algebra properly. All right. So let's do a couple more together, and then you can try some on your own. So what is the first step? The first step is to rewrite the equation. So if you said rewrite the equation, good job. What is the second step? Second step is to get y by itself. So we have to do the opposite of subtracting 3, which is adding 3, and we have to do that to both sides of the equation. Now again, if the 100 were over here, it would be so easy, it would be so easy just to add 3 on the right side of that negative 100. The problem is 100 is not it's not over to the left, so we can't add 3 here. That would just be too sloppy. So we have to add 3 here. Now this is something that we haven't done yet. We don't have to write a plus 3. You can write a plus 3 if you want to, but it's not really necessary. What you're going to find as you go through algebra is that the sign of a number is always to the left of the number. So if you don't see anything here, that means it's a plus 3. And 3 minus 100 is the same thing as 3 plus negative 100. These are all things that that you're going to have to learn. Also, you can write the negative 100 on this side and add the 3. I guess I already talked about that. So these 3's cancel out. You're left with y. And over here you have 3 minus 100, which is negative 97. Again, the notation is very confusing here. But you're just going to have to get used to it. There's no way around this. You can try to take the easy way out, but you're going to get hit hard when you go up into upper math levels because you may not know the proper math notation. If you follow my rules here, you're not going to have any serious problems when you go into upper math. But a lot of students complain about this. A lot of students say, I don't like your notation. I don't like what you're making me do. But if you want to learn fluency in algebra, then there's no way around this. All right. So on to number 15. And we're just going to do 2 more problems, I think, before you try some on your own. So what is the first step? The first step is to rewrite the equation. If you said rewrite the equation, good job. What is the second step? If you said isolate the letter, the variable, the unknown, good job. So this is x divided by 9, so we have to do the opposite of division, which is multiplication, and we show multiplication with parentheses. So these 9's cancel out, and you're left with x. And then we have negative 11 times 9, which is negative 99. So if you got negative 99, well, we did that one together. All right, so let's try one more of these before you do some on your own. So the first step is rewrite. Second step is to isolate the variable. Y is not by itself on one side of the equation because the 6 is next to it, so we have to get rid of the 6. Now we have to ask ourselves, what is the 6 doing to y? Well, we learned in previous classes that when a number is right next to a letter, that means multiplication. So the opposite of multiplication is division. So how do we show division in algebra? With a fraction sign. Again, there's a lot of stuff that I'm showing you here all at once. So it's a lot to take in. So these 6's cancel out. You're left with y. And here you're left with negative 9 over 6. But this is something new that we haven't encountered today. This fraction is not reduced. I can't remember if we had one of those problems actually. But we do have to reduce this fraction. So we can use the fundamental principle of fractions and divide both sides of this fraction by 3 to get negative 3 over 2, and that's the final answer. All right, so now I just want you to be aware that typically students will have some trouble with this. You're going to get stuck in certain points because of the notation, but that's okay. As long as you can do most of this without any problem, you should be fine. Okay, so on to number 17. Now, why don't you try number 17, and when you come back, we'll do it together. All right, we're back. So rewrite the equation. Subtract 7 from both sides of the equation. And this is the part that you may have had trouble with. And we're left with z equals 3. So if you got z equals 3, good job. All right, number 18. Go ahead and try number 18, and when you come back, we'll do it together. All right, we're back. The first thing we do is rewrite the equation. Then we add 2 to both sides. And that part is the part you may have had trouble with as far as the notation goes. 2 minus 5 is negative 3. So if you had trouble with that and you got the wrong answer, that's okay. Just look at the how to do it here. And again, you could move the negative 5 over, but we don't really want to do that because then it would start to get confusing because these negative 5s wouldn't be in the same location. We want to see the progression of our work as we go down. All right. So try 19, and when you're done, we'll do it together. All right, we're back. Multiply both sides by negative 5. Whoops, I forgot to put the negative on my 8. So multiplying both sides by negative 5. The negative 5s cancel out on the left side, and negative 8 times negative 5 is 40. The hardest part about this stuff is the notation. I'm going to leave that so you can see that number 19 as we go on to the next one. So if you got 40 for number 19, good job. So number 20, go ahead and attempt that one, and when you come back, we'll do it together. All right, we're back. So for this one, we actually ended up with a fraction, and you can just leave it as 4/5. Now, a lot of students are going to try to convert this to a decimal. Why convert it to a decimal? You don't need to. You can just write it as 4/5. Unless your teacher wants you to convert it to a decimal, you really don't need to. All right, try number 21, and when you come back, we'll do it together. All right, we're back. We're going to subtract 6 from both sides, and this is the part that is confusing to students, because you have to add a plus in front of the y. The reason that you can't just put negative 6 next to the y is because if you do that, it looks like you're multiplying negative 6 by y. Very, very confusing for students. It was confusing for me when I had to do this stuff for the first time. It's confusing for every scientist and every engineer when they have to learn it for the first time, but it's just something you got to do if you want to know the language of algebra. Now, negative 5 minus 6, what would that be? Well, if you said negative 11, you were correct. So if you got negative 11 for 21, good job. All right, try number 22, and when you come back, we'll do it together. All right, we're back. Subtract 11 from both sides. And the 11s cancel out on the right side of the equation, and on the left side of the equation, negative 11 plus 4 is 7. So if you got x equals 7, or excuse me, negative 7, I almost made a mistake there. Should be negative 7. So if you got negative 7, good job. All right, for 23, we got a star by it, so something's going to happen. So let's do that one together. And we're going to divide both sides by -8. The -8's cancel out on the left side of the equation, so you're left with x. And then here we have -4 over -8. So that's going to be a fraction, but we have to reduce that fraction. We're going to use the fundamental principle of fractions. So we're going to divide both sides by 4. 4 divided by 4 is 1, and 8 divided by 4 is 2. And we have a negative in the numerator and a negative in the denominator. So those negatives are going to cancel each other out, and you're just going to be left with positive 1/2. Another way of thinking about that is the fraction sign means division. So you're dividing a negative by a negative. Like signs mean they like each other. It's a positive situation. So if you let's go on to the next one. Why don't you try 24, and when you come back, we'll do... Actually, you know what? I didn't talk about why there's a star here. There's a star because the numerator ended up being 1. We'll do more of those problems later. All right, 24. Attempt that one, and when you come back, we'll do it together. All right, we're back. That's y divided by 4, so we have to multiply by 4. In algebra, we show multiplication with parentheses. The 4's cancel out on the left side of the equation, and 2 times 4 is 8. So if you got 8, good job. All right, try 25, and when you come back, we'll do it together. All right, we're back. Subtract 9 from both sides of the equation, and this is where the trouble is going to come. The 9's cancel out on the right side of the equation, and -9 plus 12 is positive 3, so if you got positive 3, good job. All right, number 26, we got a star, so let's do that one together. We're going to rewrite the equation. And the reason it has a star is because instead of z minus 4, I wrote -4 plus z. So that's pretty much the same thing. You got to get used to all these types of notation. It takes a while to learn this notation. Remember, at the beginning of the course, I said the most difficult thing is adding or subtracting negative numbers, and that's the issues with these numbers. That's where you're going to have some trouble. All right, so we have to get rid of this -4. So we have to add 4. Adding 4 is the opposite of adding -4. And over here, you're going to put the 4. And a lot of students are going to put a 4 here with a plus here. That's not proper notation. You can't have a positive with a negative. Some students might put a positive and a 4 here. It's really not necessary for you to put a 4 or to put a positive. You do have to put the 4. So again, all of this stuff is going to cause confusion, but that's just because you're not fluent in the algebra. That's the purpose of this class. So the 4's on the right side of the equation are going to cancel out. On the left side, you have 4 minus 1 is 3, and so z equals 3. So that was a different problem because we had we're adding a negative rather than just subtracting a positive. It's really the same situation, but it looks a lot different on paper. All right, try number 27, and when you come back, we'll do it together. All right, we're back. We're going to divide both sides because that's -6 times x, so we have to do the opposite of multiplication, which is dividing by -6. The fraction sign means division. That's how we show division. The -6's cancel out, and we have 12 divided by -6, which is -2. So if you got -2, good job. Try 28, and when you come back, we'll do it together. All right, we're back. All right, so we have to get rid of the 10, so that's z divided by 10, so the opposite of division is multiplication. We show multiplication with parentheses. Now here's a very important point. This is the type of thing that can really get you in trouble. If you show 10 here with parentheses, it looks like you're subtracting 8 from 10. It looks like you're saying, I want 10 minus 8. We can't do that. So in this case, what we have to do is we have to either put the parentheses around the negative 8. That's okay. But that's kind of confusing because we have the parentheses around the 10 here. We'd like to put parentheses around the 10 here so we can see what we're doing on both sides of the equation. So another way to do it is to put parentheses on both these numbers. These are just little things that you're going to have to get used to as we go through this class, and we're going to go on to two-step equations in the next class. And when we do that, we're going to get more practice with this, and then you're going to go on to three-step equations, and you're going to get more practice, and then 4, and then 5, and then you're going to become a master at algebra by the time you're done with this course. All right, so 10s cancel out. You're left with z. 10 times negative 8 is negative 80. So if you got negative 80, good job. And we have a star because we haven't done a problem where you add a negative 8 or a negative number with parentheses and an addition sign. So we have to do the opposite of adding negative 8, which is just adding 8. Opposite of adding negative 8 is adding positive 8. So we just added a positive 8. And again, you have to get used to this notation over here. So these cancel out, and you're left with x. And 8 minus 13 is negative 5. So the answer is negative 5. All right, so why don't you try number 30, and when you come back, we'll do it together. All right, we're back. So we have to subtract 14 from both sides. Fourteens cancel out on the left side, and you're left with negative 6 on the right side. So if you got negative 6, good job. All right, try 31, and when you come back, we'll do it together. All right, we're back. And we're going to, this is multiplication, so we have to divide both sides by 2. And in algebra, you show division with the fraction sign. The 2's cancel out on the left side of the equation. And you can just leave it as negative 3 over 2. So we got negative 3 over 2. Good job. All right, try number 32. When you come back, we'll do it together. All right, we're back. So we'll rewrite the equation as usual. We have to get y by itself. So the fraction sign means division. So that's y divided by negative 7. So the opposite of division is multiplication. We show multiplication with parentheses in algebra. The negative 7's cancel out, and you're left with y equals negative 63. All right, so we're done with the class today. That was a faster class than usual. You deserve a break from the last class. The last class was pretty involved. Now this is everything that we did today. If you'd like to take screenshots of these pages to help you with the homework or to help study for tests, you can go ahead and take a screenshot and then take a screenshot of the third and fourth pages. And those pages will be a big help for you for the homework if you want to put those pages in your notes. So here's the homework. 20 problems. Take a screenshot. And you have all the answers. Make sure to check all your answers. And I want to tell you right now that the most important part of the homework is showing your work, and I want you to show your work exactly the way that I showed the work here. I want you to rewrite the equation. I want you to show the operation you're performing on both sides of the equation, and I want you to show the algebra on the same line. Show the operation on the same line. Don't pull that trick. Don't pull that trick that a lot of teachers pull. You have to write the operation on the same line. You have to rectangular your answer. Do it exactly the way that I did it, and you have to show the work. So that means you're going to have to rewrite all these equations on a separate piece of paper, and you're going to have to give yourself room, just like I give you room here. So space out the problems. Write the original problem. Don't mess up the original problem. You need a record of your work. Rewrite the problem. Isolate the variable. Rectangle your answers, so on and so forth. It's extremely important that you do all of that. That's the purpose of this class, is to show you how to show your work, because things are going to get involved as we go into 2-step, 3-step, 4-step, and 5-step equations. So get that homework done. Make sure that all the answers are correct, and if they're not correct, fix them. Don't just leave it incorrect. So I'll look forward to seeing you in the next class.